Welcome to the Brazil-Finland Seminar on 6G Network Development, organized by the Embassy of Brazil to Finland, with the valuable support of the Embassy of Finland to Brazil, the Consulate General of Finland in São Paulo, and Business Finland. I am Najara Sena, Head of the Science, Technology, and Innovation Promotion Sector at the Embassy of Brazil to Finland. Today, we will have an overview on how Brazil and Finland are endeavoring efforts, from research to national and regional policies, to develop a new architecture of networks that will support future technologies of the sixth generation. To open this seminar, I would like to invite the Ambassador of Brazil to Finland, Mr. Luiz Balduino, to say some welcoming words. Ambassador, you have the floor.
To all of you who follow us in Brazil, and good afternoon to those who follow us here in Helsinki, in Finland, also Oulu and other parts of the country. I would like to thank especially Mr. Kari Purunen, Consul General of Finland in São Paulo, Mr. José Gontijo, Secretary of Entrepreneurship and Innovation in the MCTI in Brazil, who will participate through a video, Mr. Petri Lehikoinen, Deputy Director General at the Finnish Transport and Communications Agency, and Professors Luciano Mendes from Inatel, Mati Latva-Aho from the University of Oulu, and Rodrigo Cavalcanti from the Federal University of Ceará. I have just a couple of messages related to this seminar, whose main objective at this juncture is to raise awareness to this cooperation, which, in my view, is one of the most important activities in the bilateral relationship between Brazil and Finland. The University of Oulu is a hub on 6G research involving several countries and universities and industries, and the cooperation of Brazilian universities in this process, the 6G flagship, has the potential to bring significant positive impact for the Brazilian society and economy in the future. So I think this is the first message. I think it's we need to cherish this collaboration very much, given the prospects that it brings to all of us. The second message is that this is a long-haul flight. It's a cooperation who will bring fruits in 10 years, 12 years' time, who knows. And most of us who are here today will not be in the same position when this cooperation bear fruits in the future. So it's very important that we have in both sides a continuous engagement. There will be several Brazilian governments who will go through this process. Also in the universities, there will be changes. And it will be important that as we move forward, that efforts related to budget, to people allocation, and other allocations, which show a continued commitment, can be maintained so that we can see that this can see the light after some time. I think the potential is very big. I think we have the right institutions on the Brazilian side, and I'm very hopeful that this will bring concrete results to all of us. So thank you very much, and I wish you all a very positive and productive seminar. Thank you, Najara. Floor back to you.
Thank you, Ambassador Luiz Balduino. Now, I would like to invite Mr. Kari Purunen, Consul of Finland in São Paulo, for a short introduction. Consul, you have the floor now. Yes. Okay. We cannot listen. One moment.
Okay, let me just try.
Yes. No, it's now. Okay.
Can you hear me?
Yes, we can.
Oh, excellent. Very good. So good. I'm here. So many thanks for the opportunity to speak at this important event, and special thanks to Ambassador Luis Balduino and his excellent team at the Embassy of Brazil in Helsinki for making this important event happen. I'd like to stress that Brazil is Finland's most important trading partner in Latin America, and it is one of the largest economies in the world and offers great opportunities for both commerce and cooperation in innovation. Brazil is also a solid democracy based on the rule of law and a genuine market economy. We all saw the recent elections here in Brazil in October, and it was just amazing how smoothly it went and how solid the democratic institutions were in Brazil. There were like around 120 million votes that were counted, and the result was out in 3 hours after voting ended. So it was a true feat of democracy, and shows the resilience and strength of Brazil's democracy. And because of that, Brazil offers a great environment for both business and innovation. For its part, Finland is a highly advanced economy that produces some of the world's cutting-edge technology. It is important to point out that Finland offers sophisticated technological solutions to Brazilian companies and partners that allow them to develop and become more competitive in the global marketplace. It is clearly a win-win situation for both Finnish and Brazilian parties. Specifically in network technology, Finland is one of the 2 Western providers of 5G technology, especially networks. And it's important to stress that technology, and especially network technology, is at the center of international relations and the increasing rivalry between the great powers. Finland offers solutions based on democratic values of an open society that do not pose any threats to national security. We are also at the forefront of developing 6G technology. The 6G flagship led by the University of Oulu is one of the most important centers in the world for developing 6G. In addition to Oulu, we have a nationwide 6G research and development community. Several companies and research institutions founded last spring a joint coalition, 6G Finland, to advance Finnish research and to develop international cooperation with like-minded partners such as Brazil. Finland's 6G research is based on human-centric approach with particular emphasis on sustainable development, security, trust, and privacy. 6G will be significantly smarter than previous network generations. Finland's particular strength is its holistic approach to 6G development that encompasses artificial intelligence, edge and embedded computing, and even the development of new materials. It is important to remember that the development of new wireless mobile technologies is always based on previous generations. Therefore, it is possible to kickstart international cooperation by cooperating in 5G and 5G advanced, and then continue to 6G cooperation. To conclude, Brazil and Finland are like-minded partners with an excellent bilateral relationship. There is great potential for mutually beneficial cooperation in 6G and other key technologies. I hope this event will lead to future partnerships in technological research and innovation between our 2 countries. Thank you again for the opportunity to speak at this important event, and I hope you will all have very fruitful discussions. And once again, thank you very much to the Embassy of Brazil in Helsinki and Ambassador Luis Balduino for organizing this great event. Thank you so much.
Thank you, Consul Kari Purunen. I would like to encourage you all to ask the lecturers questions using the chat. Please briefly introduce yourself first, telling us your name and institution or city, and if possible, to whom the question should be addressed. I will report the questions to the lecturers after their presentations. Now, we are going to watch a recorded video by the Secretary of Entrepreneurship and Innovation from the Brazilian Ministry of Science, Technology and Innovation, Mr. José Gontijo. José Gontijo holds a bachelor's degree in electrical engineering at the University of Brasilia, with a specialization in public management in science and technology. He is a career public servant at the Ministry of Science, Technology and Innovation, and currently the Secretary of Entrepreneurship and Innovation at that same ministry. Let us now hear from Mr. José Gontijo about the Brazilian telecommunications ecosystem and the main official initiatives carried out so far.
Well, good morning, everyone. Thank you to be here. It's a pleasure to share with all these stakeholders this meeting that will talk about the development of the ecosystem for 6G mobile communication technology between Brazil and Finland. I will present Brazilian government actions for the 6th generation of mobile communication. I'm José Gustavo Sampaio Gontijo, the Secretary for Entrepreneurship Innovation of Ministry of Science, Technology and Innovation in Brazil. Well, we will present the Brazilian mobile ecosystem, our initiatives in the ministry, and we think we see that in Brazil we have many stakeholders, many governmental institutions that deal with this approach, look into policy to develop technologies. We have now our national telecommunication agency, the regulator for telecommunication, that deals with the spectrum management, the telecommunication services, the competitiveness and the auctions for implement the technology in Brazil. We have also the digital policies that is organized between the Ministry of Communication, look to the telecommunication policies, and also with our ministry that we are the Executive Secretariat for the Digital Strategy in Brazil. That's it's a joint committee between many ministries, and we deal with the National Internet of Things Plan, the National Artificial Intelligence Strategy, and all the legislation that deal with that. We have also the civil society, the organized civil society that look for the digital economy, the quality of life of the people, the data protection authority, and also we think that we have to engage everyone together with the companies, the telcos and the industry in the R&D center to design tests, to look for standardization, harmonization, and applications. So in Brazil, we have advanced mobile communication R&D projects that are coordinated by our ministry. In 2022, we invested around a little bit more 100 million reais that we implemented 5G ranges, European Brazil project. We have the project 5G on IoT focus on applications using 5G and IoT. We have 5G in a box that develop a hardware, a low-cost hardware to implement in rural areas and for the usage for small operators. We have also 6G Brazil project. That's a joint project between the main R&D centers in Brazil and also bringing the companies to develop and looking and foresee the next 10 years technological development to Brazil be ready for the next generation, and also the Open Run MCTI Brazil. That's also a big project that we are dealing with, that looking to how Brazil will be prepared to this technology. At the end of the day, the 6G will be project in Brazil will be an initiative that brings around 11 R&D institutions in Brazil, the main R&D institutions on telecommunication in Brazil, that's coordinated by RNP. And Inatel is the technical coordinator. We have in this project as general objectives, the creation of an ecosystem for the development of 6G networks in Brazil, ensuring compliance with strategic verticals for the country, because in our view, the country that prioritizes everything prioritizes nothing. So we have to prioritize some specific areas. In the past policies, we choose 4 main areas, 2 very attached to the GDP in the country, industry and agribusiness, and other very attached to the quality of life of the citizens, health and digital cities. So, and looking to that, we are trying to make Brazil as a relevant actor in the process of defining the future mobile communication network and applications. Analyzing the use of cases in this phase 1 of this project and looking as how will be the requirements of this network and what would be the best capacity building that are required to implement this technology in Brazil, to develop the solutions and the applications. So we are preparing the survey of state of the art of enabling technology for 6G networks. What would be? It will be holography, it will be tactile internet, it will be, there are so many aspects that can be engaged in the 6G technology that we are trying to bring all these stakeholders to give us the feedback to implement the best policies, and then contribute for the state of art in 6G networks so that the use of cases will be considered relevant, not only for Brazil, for worldwide. Bring all this knowledge for 3GPP, for ITU, for all the main standardization forums in the world. The execution methodology of this project, it's a working group focused on essential themes for 6G, use cases requirements, artificial intelligence, position imaging sensing, access networks, antennas, RF, optical communications, and 6G architecture. The phases of this project will be split in also phase 1, 2, and 3. The phase 2, conceiving a technological solution to support use cases in Brazil and build the skills, the capacity building of the people. We don't. If you have technology but you don't have brains to push this, to develop the solutions, it don't make sense. We have to have people. Build the Brazil 6G platform to evaluate performance and demonstrate transfer technology to the market. And I'm not saying that Brazil have your own closed 6G technology platform. It's another aspect. We are looking for bring all the stakeholders to join and develop this technology with us. In Brazil, we have Ericsson, we have Huawei, we have ZTE, we have Nokia, we have all the main manufacturers of 6G and companies that develop the technology. We have many telcos that are interested in developing this technology. What we are trying to do is bring all these stakeholders together to Brazil be prepared and be ready and contribute for the standardization and the development of this new technology in Brazil and worldwide also. And then in the execution methodology, we conceive new technologies, create intelligent platforms for 6G network, train human researchers, create search networks, transfer technology to the industry, and also conduct field tests for demonstrations. Attached to this and running parallel, we have the Open Run project. The Open Run, it's a technology that we are trying to develop, looking what's happening in the world, bringing a low-cost implementation, giving the possibility to another industry stakeholders engage their solutions to the established vendors. And thinking about that, probably the 6G network will have lots of Open Run requirements. Looking to that, Brazil started an Open Run project, a huge project in the country that will be split in 3 phases. They're running phase 1 and 2 already. It's around 100 million reais, and the phase 3 will be starting the next months. The phase 1 is start up test bed, understand the technology of Open Run, develop some applications. The phase 2 will be start to develop the hardware for Open Run. And then the final phase will be the test bed for this hardware that have developed it and look to the edge applications that will bring us the real future for the Open Run and how these Open Run networks will connect to the legacy networks. I guess the main trigger, the main objective of this Open Run probably will be who will find the way to connect the Open Run networks with the legacy networks and how to do this in a best way, look into cybersecurity, look to efficiency of network management. Well, we have also our National Telecommunication Agency implement a group to study Open RAN technology and 5G and 6G and so on, but start with Open RAN to look how we could implement this technology in Brazil, look into certification, to security, economic aspects, regulatory aspects, mapping, analyzing all the ecosystem that we have in Brazil, and it's the targets, the final report will be ready by April next year, 2023. And by the end of this year, we launch a lot of calls for fostering 5G solutions in Brazil. We have a call for 5G applications over private networks, and we have a lot of funding money through FINEP, that's a national funding agency for R&D and innovation, with a very good fees for give this money to the entrepreneurships to implement solutions. So looking to that and looking to all these ecosystems that we are preparing in Brazil, we think that this partnership between Brazil and Finland and through University of Oulu and also Inatel, we have this possibility to engage even more our ecosystem and together being a very key and important actor in the next 10 years mobile communication development and standardization. So we salute all the stakeholders here in this meeting in Finland and in Brazil. And we here in the government, federal government, we are very glad to see that this project is running well. And maybe in the next months, in the next years, we will see a Finland-Brazil solution worldwide implemented in this technology. Thank you.
Ministry of Science, Technology and Innovation.
I agree that we already are very proud of our R&D institutions and longing to see new Brazil-Finland solutions for mobile communications and the standardization. Now, I would like to invite Mr. Petri Lehikoinen, Deputy Director General at the Finnish Transport and Communications Agency, Traficom. He has long been dealing with public mobile networks from 2 to 6G, fixed and mobile broadband networks, standardization, numbering, roaming, and significant market power issues. Today, he will share a brief history of the evolution of telecom networks in Finland with us, lessons learned, and policies for the future. Mr. Lehikoinen, the floor is yours.
Yes, thank you for the invitation to speak on this seminar. I'm very happy to be here and share some of our experience and views on mobile networks and explain some of our priorities or actions that we believe need to be taken in the future 6G work. So I'm Petri Lehikoinen, Deputy Director General at Traficom. Here is just don't be scared. I will not go into details, but basically the Traficom is the Finnish Transport and Communications Agency, and our mission is to build the connections that keep people, data, and goods moving smoothly, surely, and sustainably. We build the operational reliability by improving security when it comes to transport and digital society. We strive to provide quality and affordable services in the transportation and connections sector, and we ensure that people-centric and sustainable services will continue to be built in the future. So shortly, we are about 1,000 people in the agency, and as the name Transport and Communications Agency states, we deal with the transport and communications parts of our administration. And maybe to point out that we also have the National Cybersecurity Center within Traficom, and I come from the digital connections, which is responsible, for instance, for the 6G work. Shortly, I'm sure you have seen something like this before, but just to remind us that it's been quite some time already that we have had mobile networks. So it all started with the analog voice calls in the 80s. Then came the digitalization and with the GSM in Europe. And we have at that time, the killer application was the text messaging. And at least we Finns, we sent SMSs by the billions. Then moving on to the, let's say, mobile broadband, the first phase was, of course, with the 3G at the 2000s, but let's more importantly, maybe with the 4G when we had the IP-based network and we had the fast mobile broadband that is capable of 100 megabits. And now we are entering the 5G era, and in which we have the enhanced mobile broadband, virtualization, different cloud services, IoT, and ultra reliable communications. And of course, the focus of this point of this seminar, the 6G, which will come, well, maybe at the end of this decade or early 2030s, where we have words like immersive, extreme, and ultramassive communications, broadband to everyone or global broadband, and etc. And to relate this to Finland, we basically, what we have done in Finland, we have, let's say, all the frequencies available that have been decided on the ITUR level. They have been granted to operators, and we have 3 nationwide operators in Finland, and they have all of them. They have about 1/3 of the frequency band, so the 700, 800, 900, 1800, 2 gigahertz, 2.6, 3.5, and 26 gigahertz. So they have plenty of frequencies that they can use. And we have been let's say, the 900, 1800, and 2 gigahertz bands were rewarded on the 90s and early 2000s by beauty contests to the operators. But since 2009, we have held auctions to give the licenses for the other frequency bands. And I think one of the things that we believe is that has been good for the mobile sector in Finland is that even when we have used the auctions, there has not been fiscal goals on the auctions. So basically the prices that the operators have paid for the frequencies have been, let's say, affordable. And that has actually created such a situation that in Finland at this point in time, we have 99.9% population coverage with the different networks. So 2G, 3G, and 4G. And also with the 5G, it's roughly 85% of the households have a possibility to connect to the 5G network. So basically we have had good results, and it also the prices for the operator that they give for the data cards or SIM cards, it's relatively inexpensive, and they are of unlimited data. So basically, if you have a 4G smartphone, you can basically use it as much as you like with the fixed price. Another important thing we believe is the technology neutrality. So all of these bands can actually be used for any generation of wireless networks. So at this moment, for 5G, the operators use 700, 3.5 gigahertz, and 26 gigahertz. But for instance, at 900, the operators have 2G, 3G, and 4G networks. So it's our licenses are such that they give the freedom for the operators to choose what technology they use, because it's not really about the whatever the generation of the wireless network it is. It's what it can provide. So we have give the operators freedom. Then on the more recent development is that we used to have only nationwide licenses, but we have started to, because there has been a lot of interest, and we have been asked for a local network. So we have also opened up 2 frequency bands for local networks, and we are thinking of opening up a new one at 3.8 to 4.2. So I think this is actually a quite important issue and part of the future 6G works, to how to make also the local networks possible with ease, so that there is no so that they can be freely used. So that's basically what we have done in Finland, and we have had relatively good results on that. Then if you move on to the 6G or IMT for 2020 and beyond, if you use the ITUR words, well, in simple terms, you could say that 6G will connect many or all devices, processes, and humans to a global information grid cognitively. Thereby, it offers new opportunities for various users and verticals. The key functionalities or of it are, or what we wish it to be or aim to it have is, for instance, energy efficiency, sensing resolution, full connectivity, and security. And I'm sure you will hear more about what are actually the capabilities or possibilities of the 5G, of the 6G. And this picture that I show here, it just tries to highlight some of the things that we believe need to be taken into account when developing the 6G. So basically, first, you need to have let's say, the high-level goals or vision, if you like. So basically the questions why we are doing this. And then there are some questions that needs to be answered when defining this. Then you need to think to whom we actually need to develop this 6G. Then there are basically to do the work and make the technical work. And so we actually need to come up with the user scenarios, and we need to think what are the technological enablers and capabilities that are required to meet the goals that we have set for the 5G. And this work is carried out right now in the ITUR, and the 6G, let's say the vision will be defined in the next 1 or 2 years, after which the more exact requirements that are required to meet the vision are defined. And at the end of this decade, we move into the standardization part. So there is a lot of work that needs to be done at this moment, and now is the right time to do it within the ITUR. And then if you look what are let's say, some of the building blocks or key items that we need in order to have the 6G in future. Obviously, you need spectrum to utilize the network. And of course, you can use as in Finland, as I mentioned, it's possible to use the existing bands also for 6G at the time when the 6G is available. But you need more frequencies. You need, especially you need the, let's say, the sub-terahertz frequencies for the very, very, very high throughput networks. So there is a requirement for a new spectrum also. There's a lot of international work and collaboration that needs to be done. At the moment, of course, there is the ITUR work for the IMT vision and definition and standardization that is ongoing. Then relating to the spectrum issues, you have the World Radio Conferences. The next one is 23 next year, and the one after that is 27. So those are the places that we need to have discussions about new frequencies. And then there are some a list of some European groups that do the 6G work as well. But I think the one important issue is the regulation. So basically, we need to have, let's say, nationally licensing regimes that are flexible and can provide for different type of applications and services to be provided. So that is an area that needs to some work. At least in Finland, and I believe in many other countries. We need to make the regulation in such a way that it allows efficient use of the spectrum. So basically, a dynamic spectrum use or spectrum sharing is important. Also, if you look at the global connectivity part, you may need, or you need also satellite and the regulation concerning the satellite issues and using terrestrial networks and satellite networks at this point in time is rather difficult. So that's one thing that we need to look into future. And of course, security or cybersecurity is an important part of this puzzle. And then you need a lot of cooperation, and here are some examples of cooperation that we do actually in Finland. But then to summarize, what we need to focus on. So basically, if we want to have the 6G to be a success, so we believe that we need to do more cooperation nationally and internationally. So we need to increase the operations on the R&D part, and also within the companies the willingness to use at this point in 5G and in future 6G for these new services. Internationally, I think this is what we are doing right now. We need to discuss among ourselves and between countries and different fora, and we need to strengthen the cooperation. And then also the companies need to actually do maybe a little bit more and a little bit more open cooperation, so that we can have more open, let's say, standards or standards that are easily, well, not easily, but basically that more companies could actually, for instance, build 6G networks in the future. Of course, we need new frequencies, as I mentioned, and one thing that I might also maybe stress a little bit, that we do need the 6G network to be secure. I mean, we need already the existing networks to be secure, but the more and more we rely on the networks, the more secure they have to be. So we have to build the next networks in such a way that they are trusted, that people are willing to use them, and they see that as an improvement to the existing networks. And the regulation that we have, we need to make it enabling both nationally and internationally. And to conclude, in a way, it's maybe good to remember that even though we put a lot of emphasis now on 6G, and whatever the 6G will be in future, it will not be the ultimate communication system. There will be new development and improvements in the future. So there will be 7G, there will be 8G, etc. And to us, it's not so much about what is the generation of the network, let's say present and coming. It is more what it's enabling us to do. With that, I would like to conclude my presentation and thank you once more for letting me speak here. Thank you.
Thank you, Mr. Lehikoinen. I would like to encourage you all again to ask the lecturers questions using the chat. Please briefly introduce yourself first, telling us your name and institution or city, and if possible, to whom the question should be addressed. I will report the questions to the lecturers after their presentations. Now, I would like to invite Professor Luciano Mendes from the National Institute of Telecommunications Inatel in Brazil. Luciano Leonel Mendes received the Electrical Engineering and Master in Telecommunications degrees from the National Institute of Telecommunications Inatel in 2001 and 2003. He received the doctoral degree in Electrical Engineering from the State University of Campinas, Unicamp, in 2007. He is full professor at Inatel, where he has lectured in undergraduate and graduate courses since 2001. He is also the technical coordinator of the Radio Communication Reference Center and the Brazil 6G project, both hosted by Inatel. Professor Luciano, the floor is yours.
Thank you very much. I will share my screen now. I hope you can see my slides. First of all, I'd like to thank the Embassy of Brazil to Finland for this opportunity for bringing us together to discuss such important technology for Brazil. So as I have been introduced, my name is Luciano Mendes. I'm the coordinator for the Brazil 6G project. And my goal today is to present the main goals, user case, and challenges for 6G networks in Brazil. First of all, I'd like to tell you that this is not a local effort at Inatel, but a national effort that is being done by several research institutes in Brazil. So these are the partners that are collaborating to the development of 6G ecosystems. So Secretary Gontijo has already introduced the project, the goals, and what they're trying to do. So I will provide you some more details about what these universities are doing and how you are cooperating towards the evolution of mobile communication in Brazil. So first of all, you need to understand why you need to evolve to 6G networks. And you are now seeing that 5G networks are being deployed in Brazil. So a very good question is, why are you already looking into 6G networks since you're not completely sure about the capabilities of 5G networks? So let's understand a little bit what 5G will bring you to the market, right? So the first point is that we always need more data. So media is always getting large. You want a 4K video, would you like to stream our reality to the world in real time? So you need to download more data, upload more data, and for that you need to enhance the mobile broadband communication. So this is one of the pillars of 5G networks, provide higher throughput. That's what you are seeing nowadays in the current deployment. But 5G is not only this. 5G is also providing a massive machine type communication to devices that will be spread everywhere. So now you're providing a solution for Internet of Things over mobile networks. So 5G will be the gateway for IoT for future applications. And also 5G is reducing the latency using ultra-reliable low-latency communication. In this case, you are redefining what is a fast internet. Fast here is not only download and upload speeds, but actually have a shorter answer from the network to commands. So this is very important for industry, for example. So all these three scenarios together is what 5G will bring to the market in the near future. You already started doing that in Brazil, and they're gonna evolve quite fast towards these three scenarios. But if you look to those scenarios, we can see that there's something missing, right? 5G networks is providing a very good connectivities for small cells, small coverage, dense population areas, and we do have a problems regarding the remote areas, right? So there is not really a concrete action towards remote areas, and that's very important to Brazil, right? So what we can see is that you have a huge technology development for 5G networks, and the same technology can be used for remote areas, but they need to be tailored for this situation. So you cannot only use 5G as it is defined, use the same frequency that is being defined now, and try to provide connectivity to remote areas. You need to change a little bit. It's the same technology, but tailored for these new applications. And we can see that lately you had some efforts for doing that. We're expecting now the release 17 from 2GPP, which you introduce 5G New Radio Lite. It's an adaptation of the current technology that you're using today, and you're going to improve that. But we are not sure if that's good enough, and I will show you why. So why do you need 6G in Brazil, right? What's important? First of all, we see that there are several areas that are not covered today. We have a lot of remote areas that there is no coverage at all. And there are some very important verticals that are located in these areas. So Secretary Gontijo already mentioned some of them. So agribusiness, industry are two of the important verticals that has been highlighted as strategic in Brazil. I will talk a little bit more about agribusiness here, although the Brazil 6G project is not only related to this case, but I will highlight it just to understand why it's so important, right? And also, you need to understand that there are a lot of people living in these remote areas in Brazil, in rural areas in Brazil, that they have no connection at all, no opportunity to share information online. So you need to close this gap and bring these people to the digital era. So this digital inclusion is very important for the Brazilian society. And 6G networks also not only about communication, right? So it's introducing a lot of new features to the system that can be very important for those verticals, for industry, for agribusiness, for security, for smart city. And sensing, imaging, and positioning are some of those features that will be integrated to the communication to build the 6G networks. So 6G networks will be the technology to integrate the physical world, the biological world, and the virtual world in a single platform, right? So we are not only looking to communication now, but a lot of new features. And what you can see in this integration is that you need to have high throughput and low latency at the same time. For now, 5Gs provide one operation mode for high throughput and another one for low latency. You need to have those both requirements fulfilled simultaneously, which is a huge challenge. So in Brazil, you're looking to several use cases. Here's the most important one. Here you have the extreme world coverage, so internet everywhere. That's very important for Brazil because we are a continental size country, right? It's a huge country, and you need to provide connectivity everywhere for environment monitoring, for agribusiness, for border control, right? So for security. So this is the one important use case for Brazil. Also, advanced security is very important for cities, so to provide better security in cities, but also to provide new ways to control people and make sure that it's safe in public areas. Agribusiness is a very important, as I will highlight in a few seconds, and also advanced communications. With the pandemic, you start using computers to communicate a lot, as you're doing that right now, but only have audio and video, it's not enough to provide to fulfill the human requirements for communication. So you need to add another layer, another sense into this communication. So holographic communication and also tactile communications are being highlighted as important to be included in communication. So it's a lot to evolve, a lot to develop in the next years, and those are cases what they are looking here in Brazil. So, and why you need to provide a good solution for agribusiness, right? So mainly Brazil, it's a major, there's a major hole in feeding the world, right? So later in the last years, we have increased your production for soybean. Actually, we surpassed United States as the main provider of this commodity in the world. And this is just one example. We can extend that for coffee, for fruits, for other beans also. And Brazil it's I would say that's one of the main players in the world to provide food. So you need to keep with the demand, increase the production year over year, and that can only be done by increasing technology, right? So how can you use that? Another example here is the renewable energy. Brazil is an example to the world in terms of use of renewable energy for cars. So you use a sugarcane for that. And we can see that it's growing a lot. So now we are expecting to have more than 5 million hectares from today to 2030. So you need to expand the area to produce more sugarcane for cars. And of course, it would be much better if instead of extending the area used for producing this sugarcane, we can increase the productivity in the area that is already being used. So if you use technology, you can produce more with the same area, and that is our goal. How can you do that? Well, first of all, you need to understand what's happening in the field. And in order to do that, you need to get data from the field. So you need to have coverage to get the information. And one mistake that people make regarding communications in agribusiness is that they think that you just need to have some bits here and there. So just a few data being transmitted from time to time. Of course, some data is better of no information at all, but that's not enough, right? You need to have high throughput information, real-time video transmissions, collecting data from the fields for taking the actions quite fast. I will say some examples, but monitoring the cattle in the fields, make sure that you can detect the biological behavior of the cattle, so you can detect diseases quite easily, quite fast, and make sure that you can act to avoid the spread of that disease, to avoid embargoes, for example. Also, you can monitor how your production is being transported over the roads, and if the road is very bad, you're losing a lot of production over the roads. You can change the road. Could you choose another place to go in order to deliver your goodies? And also you can make some pressure over the government, make sure that the infrastructure is proper for the transportation. So you can improve logistics with this technology. And the key here, you have some example. What you're seeing here, it's a precise agriculture drone. So what you can do here, you can collect the image from the fields in real time and apply that video to the AI that can detect the areas where you need to deploy some pesticide or some fertilizer. And then a drone will be deployed to apply what you need only where you need it. So you don't need to waste a lot of chemicals in areas where it's not needed. You can reduce the pollution, you can increase the productivity, and you can reduce costs for the producers. So this is just one example of what we can do with this technology. And here you can see a scenario where a video drone is used to evaluate what's in the field. So you can recognize the health of the plantation, can make sure that the area is well irrigated, or if there is some plague that is consuming the goods in that farm, and then you can deploy those drones to combat those menaces to your production. So in order to do that, you needed to have all the technology for communications that is already being developed for 5G. It will be continue to be developed in the next years, and you needed to add other features. As I mentioned before, positioning, you need to know where everything is and where it is precisely. You need to have more data from the physical world, from the biological world, integrated with the digital data. You need also to have sensor networks to know where you can use this information, to know if you can use the spectrum. You need to develop new ways of sharing the spectrum. And of course, you need to have image integrated to the network. Over this topology, you need to have AI for helping the connectivity and also for processing the data that's being collected. So in Brazil, Secretary Gontijo also mentioned that before you are developing this 6G platform. As he has mentioned also, it's not a Brazilian 6G. It's not that. It's just an environment where researchers can test their ideas and can share it with the world. So you can test here some algorithms, for example, for MIMO detection, and make sure that your work finds in the field. And with that, you can contribute with the standardization in the future. So our idea is to have a live environment where a researcher can use it to test different ideas from different layers in different areas. And once this idea is approved, we can share it with the world and propose it to be part of the global standard. So thank you very much for your time. That's what I had to show you right now. So I return the floor to the Brazilian Embassy to Finland. Thank you.
Thank you, Professor Luciano. I would like now to invite Professor Matti Latva-Aho from the University of Oulu. Matti is director of the 6G Flagship Project, a program run by the University of Oulu, focusing on developing fundamental wireless technologies needed in the 2030 era. Professor Latva-Aho is also a global fellow with Tokyo University and has published over 500 conference and journal papers in the field of wireless communications. Professor Matti, you have the floor.
Thank you very much. So, can I have the slides on the... Okay, great. So, good morning, Brazil. Hello, everybody. Great pleasure to be here today. 6G Flagship is one of the, or probably the first major 6G research program globally. We started already in May 2018. It's a 4+4 year program funded by Academy of Finland, which is our national funding institution. And we just started second phase of the flagship this year. Results so far have been really encouraging. Our work has been widely recognized. We have been able to grow critical mass of our researchers very nicely during the first 4 years. And also scientific output has been steadily increasing, as well as the number of different projects that we have been operating within Flagship so far. Our program has quite broad research agenda, and this is something quite unique. At least I haven't encountered this type of program in other places yet. Maybe they are coming. Of course, as a university, our main goal is to carry out highest level academic research in various relevant technology areas that we see important for 6G era. Besides that, we feel very strongly that it's extremely important to be actively participating some of the regulation processes and be actively suggesting whatever is needed to be changed for the future concerning 6G. Also, some of the changes that we require for regulation are coming from future new business opportunities. So understanding this techno-economical reasoning, why something should be changed, why it's no longer enough to rely on current existing mobile network operators is important. So we have various different scenarios related to digitalization of societies in the future, what type of players and actors we need, what kind of ecosystems, value chains we must have in place in order to make these changes fast enough. Sustainability is overarching theme in most of the European research institutions these days, as we know that we have serious challenges concerning the future of our globe, and many things need to be addressed. And I dare to claim that wireless research community has not done at all enough in that respect. We can do much more, and that's why it's important to address these sustainability targets as well in the research. If you're interested, you can go to our website and download some of our white papers that have been published during the first phase of the flagship. These were produced in collaboration with 250 experts around the world. They are coming from, if I recall it right, 35 different countries and 100 organizations. And these white papers were crafted with the leadership of our senior researchers of various disciplines. So this has been really well received around the world and have been downloaded already over 1 million times. The visions and ideas there are still highly relevant, and we don't expect these to change much also concerning the coming years. One of the things that we have been addressing quite a lot, and now we are happily recognizing that this is more and more also discussed in ITUR processes and other regulative bodies. Besides these technical targets and requirements for future mobile systems, it's very, very important to talk about key values, value indicators, as we call them. These are extremely hard to quantify or measure exactly numerically, but these are extremely important issues to be discussed as a part of regulation and standards processes in the coming years. As we know, we have everywhere worries about the privacy and security of wireless and networks in general. And this is an important aspect that we must take care of. If this future vision of Internet of Things is really happening as massively as we expect, privacy and security is one of the key things to make absolutely certain that people are not afraid of their valuable information to be misused. Many other things as well related to key values, and like I said, hard to quantify, important to discuss early on. When we look a little bit back in mobile generations, there has always been what we may call killer application driving mobile generations forward. The first two generations, they were mainly voice-oriented. Then mobile broadband came into play gradually with 3G and more with 4G. And now when 5G has appeared, the key question is that, okay, what comes next? What is the killer application? Why should I bother buying 5G mobile phone as a consumer? Well, so far we are still stuck to this mobile broadband as a major use case, and not so greatly improved user experience compared to 4G, but the expectations have not disappeared anywhere. 5G has laid down huge number of expectations for productivity of society in broad sense, and those targets and requirements have not disappeared anywhere. If I would look back what European Commission stated as the targets for 5G somewhere in 2013-14, and later on ITUR made as IMT 2020 requirements in 2015, those are still valid for 6G. So it really means that these mobile generations don't happen overnight. We actually basically need 2 generations to make these frog leaps to something totally new. So when developing 6G, one of the first things that we have to make available is to really try to make sure that the targets set for 5G are really happening and coming to available for everybody. What we think, both with 5G and more so towards 6G, is that there are different very important vertical sectors which will be driving some of the technology development also for the future. This one technical solution fitting all possible problems kind of thinking has to step aside a bit. We need a lot of customization of radio access networks for different use cases. It's totally different when we are developing something like Luciano mentioned for agriculture, for example, and then compare what we need in health sector, in hospitals or industry or automotive sector. They are all very different. The players in each of these verticals are different. The technical requirements for the systems are different. And the reasons why we utilize these advanced wireless technologies in these are quite different, and the applications are, of course, totally different. So this is one of the major changes that we expect to happen when 6G standardization is eventually starting. Another important thing is that that was already pointed out by Petri Lehikoinen from Traficom, related to spectrum regulation, but I would like to broaden it to regulation in more general terms. Of course, spectrum regulation is very important for us wireless engineers and researchers, but there are field-specific regulations like in agriculture or health sector or automotive sector that have to go hand in hand with this wireless technology development. So regulative processes have to enable whatever is coming in the future. And already pointed out by Lehikoinen was this local networks appearance in the future and potentially allocating more spectrum for local networks in the future. That is very much in line how we see future happening, because more and more traffic is generated from indoors, from very local places, and we have to make sure that in such environments the networks are well suitable to the purpose. We have really tailored solutions for very specific use cases, and this is actually already happening in 5G private networks. But we need more than that, I think. Of course, when talking about 6G, it's all about higher and higher data rates, and this is very trivial way of showing how we can increase the capacity in the future. First of all, we need more spectrum. That is very clear. And now, since the lower spectrum bands are more or less occupied, we are going to higher and higher spectrum bands, talking about even sub-terahertz, upper millimeter wave bands, etc., etc. Another thing is that we have to spatially split the serving base station coverage areas to smaller and smaller cells, bringing the base stations or access points closer to end users, indoor environments, basically increasingly, so that we can reuse the same spectrum over and over again within the same geographical area. These two are the most efficient ways to increase capacity of future systems. And if you look back into history, this is exactly what has happened. The third one, improving spectrum efficiency. This is, let's say, very important for us researchers. We are playing with new transmission mechanisms. We are introducing more and more complicated but yet more efficient transmission mechanisms utilizing multi-antenna technologies, intelligent reflecting surfaces, and you name it. The potential capacity increase via this is modest compared to these other two, but still important. We have to keep pushing the technology development to the limits, and it happens over there. One example about spectrum regulation new policies we introduced already back in 2015 a micro operator concept, which is basically a local operator, which is given specific frequency bands for regional local usage. And without going into details in this, but this is really radically new idea compared to how mobile networks are operating today and existing operators. Private 5G networks is the right step towards this direction, but besides what they are doing now, for example, in Japan and Germany, these 5G private networks should also allow national roaming, so that if I build this type of local network to a shopping mall, for example, I would like that any operator customer could utilize the services that I'm offering to the visitors. So if I summarize a bit our views on what are key things towards 6G, first of all, digital inclusion via global coverage. We have to take into consideration that there is currently 4 billion people around the world without any internet connectivity. It's now about the time to make sure that everybody can get connected at reasonable cost. Usually these remote areas are poor areas, and the solutions that we are offering to metropolitan areas, wealthy countries, are not suitable for those areas necessarily, or very rarely even. And that's why we have to tailor those solutions specifically for remote area communications. And what Luciano presented earlier on this agriculture example, very much agree with that kind of thinking. We have to challenge the current MNO-centric business models, like I explained earlier. Global collaboration is these days more and more important as the world has gone a little bit turbulent during the past years, and it's very important that we can globally agree on standards for the future, as well as we are used to now for a relatively long time. Different technical key points and targets that we must be addressing. Maybe if I pick here one, the super efficient connectivity at high spectrum bands is probably the mostly on our research currently. We are talking about many different things when we talk about super efficiency. It can be extreme speeds, really high reliability. It can mean very accurate positioning or other sensing capabilities, and so forth. And mainly we are looking at very high spectrum bands when the super efficiency is discussed, as there's plenty of bandwidth to be used for achieving the efficiency. If you're interested in following some of our works, today we have published our latest 6G Waves magazine, which you can download from our website. These white papers are available there, and every June we organize, in collaboration with European Commission, this EU CNC 6G Summit event. This year it's in Gothenburg in Sweden during the first week of June. Paper submission will be opened these days, so please submit your works there and join the conference in Gothenburg. Thank you very much.
Thank you, Professor Matti. I would like to encourage you all again to ask the lecturers questions using the chat. Please briefly introduce yourself first, telling us your name and institution or city, and if possible, to whom the question should be addressed. I will report the questions to the lecturers after presentations are over. Now, I invite Professor Rodrigo Porto Cavalcanti from the Federal University of Ceará. Rodrigo Porto Cavalcanti has been at the forefront of mobile communications research in Brazil for over 20 years. As the founder and leader of GTEL, a think tank on wireless telecommunications at the Federal University of Ceará, he has led contributions for cellular systems evolution since 3G. Professor Rodrigo has led a long-term R&D cooperation with Ericsson Research, which currently focuses on the evolution of 5G and the road to 6G. He is also a research manager certified by MIT and is involved in shaping intellectual property and entrepreneurship policies for Brazilian universities. Professor Rodrigo, the floor is yours.
Thank you very much. It's a pleasure to be in this seminar. Thank you for the invitation. Thank you for organizing this seminar in this very important topic. Yes, my presentation is on the screen. I hope you see it and hear me well. This presentation is a bit about challenges and opportunities for information and communication technologies making a societal impact in Brazil's Northeast. The University Federal of Ceará in Brazil is in Brazil's Northeast. And this presentation is not that much about technology. It's a little bit more about the application of technology and how technology can address some of the challenges that we have in this part of Brazil. So it's a bit like a case study, the presentation, but I think that most of these challenges that I'll point out are relevant to other parts of the world as well. So the conclusions hopefully are valid for other parts of the world as well. So for those that are not familiar with Brazil, let me give you some context. So Brazil is among a few countries with three unique characteristics. It has a large area, landmass, which translates into an abundance of natural resources, of energy sources. It has a large population, which translates into a large internal market and abundance of labor force. And also it's a large economy with a GDP of over $1 trillion. Meaning a diversified industry and the service industry well established. So Brazil is a natural player in world's geopolitics, economics, and naturally in the ICT arena as well as a consumer of mobile communications technology for sure, one of the largest markets in the world, and as well as a country that can shape some of the characteristics of the technology that help solve some of its challenges, because some of these characteristics, like a large population, also brings lots of challenges. And going into more specifically about Brazil's Northeast and why we are talking about this particular region, Brazil is divided into 5 regions that are very different geographically one from another. They are like 5 different countries, one could argue. And Brazil's Northeast, that is this northeasternmost part of South America in this circle there, it's like a country in itself with 60 million people. And then I put the numbers from Finland to compare. Finland, 5.5 million, 1.6 million square kilometers against 0.33 for Finland. And here a first hint of the type of challenges that we have when we start to look at the ICT, the information and communications technologies aspects of it. We have in Brazil's Northeast, 60% of the households have a fixed broadband against 97% in Finland. So you start to see the type of challenges that we have as ICT becomes more and more an essential utility for everything in life, in society, having 40% of households without fixed broadband connections is an important challenge to address. In the Northeast, you find different landscapes. So we have 9 states, and most of the population, but not all, is concentrated along the shoreline. The shoreline has 3,000 kilometers of sand beaches, sunlight almost all over the year. You have big hotels and resorts. It's like a paradise on earth. And it's a strong driver for the economy of the region. It's based on tourism. Touristic service industry is one key driver. So this part has a good infrastructure, and you have 4G and now 5G in some cities. So we don't focus that much here because it's having its development going reasonably well. But as you move into inland, the landscape changes dramatically. So if you go into the inland, already on the outskirts of the major cities, you find slums, you have sanitation problems. And if you go farther into inland, you find those dry lands where there is water shortage and the infrastructure is quite poor. Of course, ICT and 5G and 4G, even 4G now, is still scarce. So you have these different landscapes, and the challenges are, of course, completely different. And I'm going to focus a little bit more on this part, which has a large population by any measure. We have talking about over 10 million people here in this part of Brazil, in this inland area, with these necessities, these needs that are clearly of all types of infrastructure that you need, but ICT in particular also is very important to address. So to sum up this context, this is a comparison of the Human Development Index. So Finland is very high with 0.94. In Brazil, you see there is differences. Brazil's south is 0.83, is considered high. Brazil as a whole is 0.75, is considered medium. And Brazil's northeast is 0.65. It's a little bit more like a country like Bangladesh. It's considered medium to low, okay? Showing these differences. So it's very difficult to talk in a country like Brazil, one solution fits all, because there are stark differences between the regions. And northeast is certainly one region that we surely have things in common with certain parts of Africa, certain parts of Asia. So solutions that are tailored to this type of geography, this type of population, will surely be also relevant to other parts of the world with similar features. So what are these challenges? Well, I've just hinted at it, but let's be a little bit more specific. So, of course, low income, it's a problem. It's a basic problem for any development that you want. But more specifically, low demographic density. If you are a telecom engineer, you probably already make the relationship that low demographic density, you have a reasonable market, but it's dispersed, is scattered through a large area. It brings already automatically a challenge in terms of capital expenditures to deploy networks, because your customers are in a wide area, and you need a lot of infrastructure to reach those customers. So to give an example of this spotty coverage, 20% of the schools in the Northeast are unconnected. And if you think of a public service that should be or must be connected, you think of public schools. And 1 out of 5 schools are unconnected in Brazil against 0% in Finland. This is a sample of the type of infrastructure investment that we need. But here is the caveat. These 20% are probably the hardest to reach. If you remember the Pareto rule, probably most of the revenue is already heaped on the 80% that are already connected. I'm talking about the population as a whole. So probably the solutions that have been, the access solutions that have been proposed and used for the majority of the cities and the communities will not do the same effect here for this last 20%. So we have to think a little bit more on both the technology side and also on the policy side to reach those last group to fill this gap. And one hint here to show how this relates to technology. Question: do non-terrestrial networks or high-altitude platform stations have a role to play here, this type of problem? So that's an example of a technology question that might have an important impact in society and community, and policy could be shaped also taking into account what are the technology options that we have. The other side of the coin of this question be, do conventional terrestrial networks can be somewhat tweaked to become more affordable and to be able to address this gap as opposed to non-terrestrial ones, or a combination of both. So this is one example of how technology question, technology decision capability can influence deployment, can influence policy and societal impact. Cost is, of course, a barrier, and that's no doubt about that. And devices are still, and smartphones especially, are still beyond the economic capabilities of many people in Brazil. So even the simplest 5G phone will take like an average of 1 month's salary of a worker in Brazil's Northeast. And we can't think of digital inclusion in terms of feature phones. That's not the type of digital inclusion we are thinking of. So we have to look at this aspect of devices to foster the adoption, the quick, faster adoption of the new technologies when they are deployed. So 5G is being deployed in Brazil now, but that will take some time and to become available to most people. And one key issue is the device cost. So it's a challenge. Other cost drivers that we have to address beyond devices, of course, but also in the network side, the core network, edge, radio access network. We'll talk a little bit about suggestions on this side. Energy efficiency, and not only in the devices, but also in the network components, to improve and reduce the consumption of energies, because energy is an important factor in composing the overall cost of operation. And spectrum, you can think of different and more modern spectrum access mechanisms that can be of lower cost to different types of operators. We'll also touch on this further on. But opportunities, let's think about a little bit of opportunities beyond the challenges. I will start making the case for renewables in the Northeast. Northeast has over 3,600 hours of sunlight per year. There's a very sunny part of the world. There is a lot of wind too, about 7 to 8 months per year, strong winds. So we already are based in the Ceará state, the state where I live. To give an example, we have the largest solar plant project in the world right now, producing 4.6 gigawatts of power. Over 1,000 wind turbines already operational. The local government just secured a $6 billion investment during the COP27 for the first green hydrogen plant in Brazil. So this is a natural vocation of the region. We were not producers of any type of energy. We don't have oil, we don't have large rivers, but then the renewables were an interesting opportunity for making this part of Brazil an energy producer. Okay, so this is one ingredient, interesting ingredient for an opportunity. What can we do with that? Lots of things, but one thing that I would like to highlight here is the possibility of locating data centers with zero carbon or almost zero carbon emissions in this part of Brazil. One thing that compounds in favor of this opportunity is the fact that in the Northeast, if you look at this corner here of South America, we have a connectivity hub in terms of subsea cables. So we have subsea cables coming and going from and to Europe, North America, and Africa. We are the shortest route to Africa, to North America, because of the subsea cables that reach here in Northeast, particularly in Fortaleza, the capital of the state of Ceará, the city where I live. So if you take the renewables, you take the hub of subsea cables, and you look at the importance of data centers for 6G, they are already very important in 5G, but we can multiply their importance in terms of providing ultra-low latency, content caching, distributed computing, cloud run. There will be the need for predictive haptic communications as well because of the latency, physical limitations of latency over large distances. So data centers will be essential. They will be probably there will be more of those data centers and more capacity. So having the possibility of relocating or building data centers in a place where you can have clean energy, I think it's an interesting opportunity. We won't have time to go into other possibilities, other use cases that are very relevant to this part of Brazil, in education, in healthcare, in community building. We can discuss this in another opportunity. We don't have right now time for that. I will just mention a little bit about policies, just a hint about potential policies for helping these people achieve their full digital citizenship. So we can discuss policy along with technology. I think there is an important interplay there, and not fully separated as we do now, or policies to be discussed after the technology is set in the standards. I think there should be more discussions in tandem between policies and technology. So infrastructure sharing, incentivize infrastructure sharing to reduce the CAPEX, the capital expenditure costs, incentivize virtualized and open run. Small and regional operators also should be incentivized to improve and increase competition. We can consider a zero rating for some applications like electronic payments. Brazil already has a good electronic payment system, but zero rating could be interesting to improve. There is, I don't have time to go into details, but there is some studies showing a strong correlation between the adoption of electronic payment and the emissions of CO2 in the whole society that has this adoption. You could think of subsidizing non-terrestrial terminals and subscriptions that are usually a bit costly. And you could also think of cross-subsidizing access for specific disadvantaged groups. These are a few hints at some policies that could be discussed, looking also at what the technology can enable and looking at the policies at the same time. To conclude, I will borrow a few words from Nokia's CEO. He has just, in a few weeks ago, in a keynote, has said that he was talking about what's the critical application for 6G, and he thinks that the metaverse is the critical application platform. And I can quote what he said. He said the metaverse can only achieve its full potential if everybody is invited into the party, if actions on the digital world are to have an effect in the physical world, then it's critical to bring internet access to people not yet served. So I couldn't agree more. I think these are excellent words to conclude this short talk. Just say that I think Finland and Brazil, although there are a large differences, of course, but Finland is a leader in mobile communications development. And I think that since it's a country that has also addressed some of these challenges that we have in Brazil, a collaboration is warranted, both in technology and in the policies that can help address these challenges. So I'm looking forward for further collaboration with colleagues at Finland. Thank you very much.
Thank you, Professor Rodrigo. We now come to the second part of the seminar, when the lecturers will answer the questions asked by the audience. So, one moment, please. Isabel Rego from Senai, São Paulo, asks, I would like to know what kind of professional technician is necessary to work with 6G, comparing with 6G teams. To answer that question?
You know, I can provide some inputs here. Well, Isabel, I believe that 5G technicians are already well formed in several areas that is important for 6G as well. If I can highlight a difference, I would say that for 6G, the professional will need more knowledge on data processing and also artificial intelligence. So they will need to train, design, and also implement new algorithms based on AI, because that is one of the main technologies for the future networks. So I think that would be the main difference, if I can point one.
Maybe I can complement that a little bit. I agree what Luciano said. Besides that, if we think about what happened from 4G to 5G and reflecting what was the target was to reduce energy consumption by 90% when moving from 4G to 5G. And I think just opposite happened. So these energy efficiency questions will be increasingly important when we move to 6G. And the developers have to think all aspects related to how to obtain energy efficiency. Now, at the same time, there's a lot of increasing discussion on Open RAN. And we know that these generic software programmable platforms, they are never energy efficient. So we have really great challenges related to energy efficiency, both in hardware implementation and also to accommodate Open RAN type of thinking to that picture. So that, I think, is something that will be more visible in the coming years.
Thank you. Another question from Jessica Hayani. Hi, my name is Jessica Hayani. I'm from SENAC National Department. How can 6G boost the emergence of new technologies?
So if I can start, then some others can continue. If you think about these future visions on application scenarios, it's a lot of those are highly automated processes of anything related to modern societies, including self-driving cars, any robotics implementations, remote surgeries. So and those require, of course, different technologies besides wireless connectivity. So there are this huge number of things that must come together in order to make this 6G era reality. So wireless connectivity is only one part of that. We need also many others.
Yeah, if I may add, as I just mentioned, this idea of the metaverse, and one of my slides I mentioned the thematic metaverse, like a healthcare metaverse. So the metaverse might seem a little bit like a video game, but it could be much more than that. So application developers looking at virtualized or digital twins applications, the potential for developing specific solutions for this type of environment, virtualized environment, is unlimited. So also adding on the previous question, I think understanding how to develop applications that can benefit from these capabilities of this type of virtualized environment, I think it will be very, very important too.
Okay, thank you. One more question by Patricia Sampaio. I would like to know in which countries 6G has started to be deployed.
Answer is simply nowhere. We are still in research phase. Standardization has not yet started. Spectrum has not yet been allocated. So I think the standard process will be active just after WRC 2017. I mean, the most active, when the 6G frequencies are allocated. And the first standard version will be ready 2018, I guess. And after that, deployment starts maybe 19, somewhere there.
Any other comment?
Perhaps you can highlight here that although the deployment is a little bit far away, the research is quite ongoing, right? So I would say that Europe is leading the research right now. Finland has a main role on this with the 6G flagship, which is the baseline for all research in the world, I would say. Also, you can see that the USA is investing a lot in 6G. I think they were a little bit behind during the 5G definition, and now they are trying to catch up. China has an important role as well as Korea and Japan. And it's interesting to say that Brazil is now trying to join this team of countries that are trying to develop this technology and defining the user case and the requirements. And it's interesting to see that you are focusing on the user case that's important to Brazil, but those user cases are also important to other countries. So there is a lot of ongoing movements towards this agribusiness, security, industry, and so on.
Thank you, Professor. Marcelo Mascarenhas is asking about the slides. Well, this presentation will be available on our YouTube and other social media channels, so you can see it whenever you want, okay? Next question. Hello, great presentation. I'm Major from Brazilian Navy. Which kind of modulation is expected to be used in 6G? OFDM, as in 5G? Thank you in advance.
Everybody has probably own opinion on that.
Yeah. That's a trick question, right? I mean, OFDM has been proved to be a very solid modulation scheme for mobile communications. It's doing well in 4G and now in the first phase of 5G as well. But it does have some shortcuts, right? So in terms of flexibility, it lacks a little bit of flexibility. It has only one dimension, which is the frequency dimension that you can try to change the parameters. Also, the out-of-band emission without filtering is quite bad. The cycle prefix efficiency can be very bad as well if the channel has a long delay profile. And it's not very friendly to fast-moving environments, right? So I would not say that it will be the unique waveform. For sure, it will be present in 6G, but I think you need also to think in other waveforms. And you do have some candidates, right? So FBMC is very good for these scenarios where you need to have very low out-of-band emissions. GFDM is very flexible to add another dimension to the parameterization of the waveforms, both time and frequency, and you can choose different pulse shapes. So I truly believe GFDM can play an important role. And also there are a lot new waveforms that they are showing up, OTFS, for example, and other kinds of non-orthogonal waveforms, which will be also relevant for future scenarios in 6G.
My few ideas to this is that in the end of the day, the implementation complexity will determine what will be deployed and what not. OFDM is very well established. There are really efficient ways to implement it. So my guess is that it will not disappear anywhere for a moment. Maybe in the future when we learn to make efficient implementations to these non-orthogonal, more generic modulation schemes, then maybe. But one important aspect is to understand that when you talk about the sub-terahertz or terahertz communications, we are always talking about more or less line-of-sight communications. So in that frequency band with really huge bandwidths, we are talking about gigahertz or more, several gigahertz bandwidth transmissions. So the modulation scheme has to be very simple. People talk about even some sort of analog modulation scheme. So no longer multi-carrier, very simple air interface, non-spectrally efficient because we can exploit, we can enjoy this huge bandwidth. We don't need to target that high spectrum efficiency always. So there might be something rather simple coming out in that domain if that frequency band proves to be useful at all for 6G. We don't know yet. We are doing research on that.
Okay, thank you, professors. Savio Neves has a question. Hi, Savio Neves, Telebras Brasilia, Brazil. Could you briefly explain the differences between the waveforms used in 4G and 5G compared to the waveforms proposed for 6G?
I would like to address that nothing has been proposed for 6G yet. Currently, the status of ITU-R work is that they are going to release, or if not released already these days, the 6G technology enablers document where at very high level the most promising 6G technologies have been addressed. We have participated at work with different proposals, but it's very general level. And it's just a listing of potentially interesting directions that the whole research and development community should pay attention to in the coming years. We don't know yet. We are doing a lot of research. In Europe, we have a very interesting project that you might be interested in following, HEXA-X and HEXA-X Phase 2. This HEXA-X2 starts next year. And in this HEXA-X2 project, it's the first time that in Europe, it's a big consortium, over 40 partners. We are part of that as well. It's led by Nokia and Ericsson. The first time that we try to come up with end-to-end overall 6G system concept proposal within the next 2.5 years. So that's the first time we try to come up with such a proposal. And lots of open research questions. It's really challenging and demanding, but we give a shot at least. We give a shot. Then we know better.
Just to complement, if you look to 4G and 5G, the waveforms are not quite different, right? So basically, in the 4G, in the uplink, what you do some sort of precoding, applying FFT before the transmission. So it's kind of a single carrier modulation for the uplink, while in 5G you use OFDM, pure FDM, in the both downlink and uplink. So that would be the main difference. So it's not really different from 4G to 5G. What happens is that in 5G you have other bandwidth for subcarriers, so you can use wider subcarriers in 5G, which is quite interesting for reducing the latency, and also interesting for improve the throughput. So interesting for example, for millimeter waves, right? And Professor Matti already answered the question about the 6G, so there is nothing defined. What you can see if you look to the papers that has been recently published in this area, we can see that there is a lot of contributions being done in no orthogonal waveforms, which completely changed the game, right? So OFDM is orthogonal, so there is no interaction between subcarriers. There is no interaction between consecutive OFDM blocks. And for these new technologies that are emerging lately, that's not the case anymore. So there is interference between subcarriers, and interference in time. And when you look to the interference, in the first moment, you can think that it is a very bad idea, right? So you're mainly making one data interfere with other data. But if you have some smart way of detection, this interference can be seen as diversity as well. So you can actually harvest some diversity from the waveform. But Professor Matt said before, it's quite true, and that's one open question. How complex and how expensive is to implement the detectors for these waveforms? Can you do that cheap? Can you make that very affordable? That's an open question, right? So you need to solve that problem before saying anything regarding using those waveforms for future mobile networks.
But one thing we know already now, and it's a trend from 4G to 5G and now towards 6G, is that the spatial domain will be utilized more and more. The number of antenna elements is drastically increasing all the time. And when we move to higher and higher spectrum bands, utilizing the spatial domain becomes more and more important. So these antenna arrays that they are suggesting for upper millimeter waves and sub-terahertz, they are enormous. They talk about thousands of antenna elements. I don't know how cost efficient it will be or can be, but that's what they talk about. So that's really clear trend. Anyways.
Any other comments?
Just add that this expansion of the spatial dimension and also the upper frequency bands towards sub-terahertz, they also enable extremely precise localization capabilities for 6G, which again adds to the previous questions about possibilities of exploiting localization applications, even in very small spaces or with very precise location in industry, but also in all sorts of societal applications, outdoor and indoor. So new capabilities, new professional skills demanded, and eventually new policies to tackle with such extreme capability of locating not only people, but objects, everything that you can think of.
That is absolutely true. And the way we see the future is that towards 6G and beyond that, the future networks will provide huge variety of new types of services that we cannot even imagine today. And communication service is only one of those. Like this extremely accurate sensing, extremely accurate positioning is a new type of service on top of which we can start to develop huge number of very interesting applications for the future. So communications is only one. All these new aspects we have to address more and more and make those happening.
Mm-hmm. Now a kind reminder from Johanna Kivimäki. Hello, I am Johanna Kivimäki, Counselor of Higher Education and Science in the Consulate of Finland, São Paulo. I will be happy to support the future collaboration efforts as needed. So you can find her on LinkedIn and other platforms. Thank you, Johanna. One question from Hannah Martinen-Dickens. Hannah Martinen-Dickens is from Business Finland, and she asks, how important do you see the collaboration between different public stakeholders as re-ensuring and enabling regulatory framework? What are your insights on that?
I can only mention that the use of public hearings for defining policies and regulations should be increased more and more. That's one way to tackle this involvement of stakeholders, public but also private and non-governmental organizations, NGOs as well. So public hearings is one instrument that is used sometimes, at least here in Brazil, by the Telecommunications Regulatory Agency and other regulatory agencies. I would say that would be an instrument to be used for ever more important decisions on the regulation that involves life-saving, sometimes life-saving decisions or high impact on how society behaves, on community building, democratic participation, etc. So the question is also a suggestion to increase this type of hearings, to have inputs from all relevant stakeholders.
I agree with that. And there are so many different regulative bodies that it's really a jungle out there. But one thing that I think we should learn from 5G regulation standards development process is that especially in Europe, we had huge riots against 5G. People started to destroy and burn base stations in some countries even. And that's because of huge misunderstanding, bad communication from developers community to the bigger audience and public. That cannot happen anymore. We should learn from that and take necessary actions early enough by different public organizations to have enough these discussions to make sure that there's no unnecessary fears from general public towards future technologies. And in general, I think we need these technologies for sustainability reasons, for example, and making sure that future societies can run smoothly. So that type of discussion is needed much more than as we have done before.
I just would like to complement what Professor Rodrigo just said. Just one example how important it is to make sure that you hear everybody before make decisions for regulation. Recently, Brazil has regulated the TV white space in Brazil, right? So now you can use TV channels that are not used in remote areas to provide connectivity. But you had a top-down decision regarding the power limitation that completely disable any kind of use in remote areas. And nobody was heard about that, right? It was a top-down decision. You're just gonna use 1 watt peak, and that's it. No discussion around it. And now you're doing some studies, and you can show that this limitation actually does not make any sense. It hinders the application of new technologies in remote areas, does not bring any benefit in terms of the incumbents, does not improve the protection at all, and we don't know where this decision come from exactly, right? So this kind of things you should try to avoid in the future to make sure that the regulation actually allows the system to fulfill the social goals, commercial goals, and so on.
Thank you. We have a message from Aldebaro Clautal, Federal University of Pará, Belém, Brazil. Thanks to the panelists for the great presentations. It's nice to see the regional diversity in Brazil here. Thank you, Professor. Also, Lasse Keisalo, many thanks for the excellent seminar. The topic is very important and timely. It's an excellent example of Brazilian-Finnish cooperation. We couldn't agree more. Thank you, Director. He's Director of the Unit for Latin America and the Caribbean at the Ministry for Foreign Affairs of Finland. And finally, Alexander Souza, Telebras, Brasilia. Congratulations on the presentations. Thank you, Alexander, for being with us. Well, I have 2 more questions to wrap up this second part of the seminar. Maybe Professor Rodrigo, could you develop a little more on how should an inclusive policy be shaped to address regional differences in Brazil? What's your opinion on that?
Yeah, that was what I tried to convey in that short presentation, is that the realities are quite different, even within one country. If the country is large enough, like Brazil, so there are stark differences in north, east, and south. So again, one size won't fit all populations, all societies. So what the basic thing is to, first of all, the regulators, for instance, to have this understanding that there should be some differences in shaping policies according to what market you are targeting. And all discussions on regulations should be very open from the onset. And then, again, I also try to convey the message that policies should be discussed in tandem with technology development, not after the technology is set. So the window of opportunity for influencing some technology decisions to help defining policies that are more akin to a particular region is already running. So that's the main point that I'd like to make to academics and regulators as well.
Okay, any other comment? Last question, if I may. What does the future of 6G in global scale look like? How can developing countries catch up this new technology so that all can enjoy the benefits of this new technology? What are your visions on that?
Well, if I may start, I think, in my opinion, we have a small misconception what is needed in different parts of the world. Well-developed societies need different solutions compared to those areas and regions which basically have nothing right now. They don't need the latest technological gadgets and toys that we may afford to have in wealthy areas. They need something for helping their daily lives. Something can be relatively simple. They have to start somewhere. So what I think we should do is to look at existing relatively cheap technologies and try to tailor-make those for their needs. That would be cheap and fast way to provide the basic connectivity levels to this type of areas.
Well, for the developing countries to join this this party, right? The first thing is to really look to your stakeholders and define what is needed for your country, right? In terms of requirements. From my point of view, as we did in Brazil for several years, right? You just expect the technology to be ready and try to use that to solve your problems, right? And most of the cases, you had success with that, but you have always some particular user case. You have some requirements that is specific for a given application, and the society should be aware of that. So researchers can get together, discuss it, and then use this knowledge to promote your user case and your requirements. And one example for doing that is the 16G Association, which is an open association. Anyone can join it for free. And you have several work groups there that you discuss how you can tackle those user cases and how you can solve those problems. And I think this kind of discussion is the first step that you need to do in order to bring developing countries in the development of new technologies.
Thank you, professors. Well, now that we don't have any questions left, I would like to invite once again Professor Matti Latva-Aho to announce a new call for talents from the 6G flagship project. Good news for today.
Okay, can I have the slides? Okay, so we are actually looking for new talents all around the world. Actually, personally, I have really good connections to Brazil, have visited there many times. I was actually visiting professor at Unicamp about 10 years ago. In our group, we have 2 professors originating from Brazil currently. And obviously, we are receiving lots of Brazilian students all the time to join our flagship. Finland is a stable country, have been chosen as the happiest country in the world for multiple years. City of Oulu is really a strange place, a small town, but yet this is one of the technology hubs globally around wireless. We have Nokia strongly present in our city and lots of other high-tech companies as well. So opportunities to work in industry here are really great. 6G flagship is the largest academic 6G program around the world currently. We have around 400 researchers at our university within 6G flagship alone. They are coming from almost 60 different countries around the world. So it's really international environment with a lot of possibilities. We do have international master program where the next application period will be opened in about 1 month, and the intake is 60 students, and this is the main venue to our PhD program. So we pick the best students from this international master program to become our PhD students. We are starting huge number of new, very exciting research projects funded by European Commission. We were very successful in the past 6G call of European Union. We were winning 12 new projects that are starting beginning of next year. We also have a national 6G bridge program funded by Business Finland starting again also beginning of next year. And we expect to have several projects from that program as well. So my guess is that we need right now about 50 new researchers at different career stages to join our flagship. So for PhD students, we offer 4-year contracts with full benefits. We employ students, and the starting salary for PhD students is about 32,000 euros per year. Before taxes, of course, you pay taxes out of that. For postdocs, we usually typically make 3-year contracts and the starting salary of 50K per year. So these are the possibilities and opportunities we offer. If in the audience anybody interested, go to our website. You will find links and instructions how to apply. Thank you for your attention.
Thank you, Professor Matti. I'm pretty sure that all this collaboration will be very beneficial for both countries, Brazil and Finland. Finally, I would also like to invite Professor Luciano Mendes again, who will announce the signature of a working plan between Inatel and the University of Oulu next year. How is it, Professor?
Thank you. Can you share my slides, please?
Yeah.
Okay, so I'm very glad to announce that Inatel and the University of Oulu has a MOU signed a few years ago during the pandemic. And now you can announce this signature of the first work plan under the 6G flagship and Brazil 6G project, right? So it's a cooperative project that now is going to have the first project running in next year, right? So the main goal is to improve the performance of the future networks for strategic user case for Brazil and Finland. And you're going to sign this working plan on February 24th at 10 a.m. at the University of Oulu in Finland. So it's a very pleasure for me to announce it, to tell you that we are working together and you're going to have some amazing results next year. Thank you.
Thank you, Professor Luciano. I agree with Director Lasse Keisalo. When the signature of this working plan is also a demonstration of how relations between Brazil and Finland are deepening very fast, and especially in the field of technology and innovation. Well, we don't have any questions left, so this brings us to the end of the Brazil-Finland Seminar on 6G Network Development. I would like to thank everyone who joined us today, and in particular, Professor Rodrigo from the Federal University of Ceará, Professor Luciano from Inatel, Professor Matti Latva-Aho from the University of Oulu, also Petri Lehikoinen from Traficom, and our Ministry for Science, Technology and Innovation, in the person of Secretary José Gontijo. And thank you, audience, for being with us here for 2 hours. And, well, last message, please follow us on our social media for more information on 6G and other R&D projects carried out by Brazil and Finland. I hope to see you soon. And thank you once again. Bye-bye.